Welcome to Beyond the Known Physics. Did you know you probably interact with artificial intelligence over 100 times every single day without even realizing it? Think about it. The movie Netflix just recommended for you? That's AI. The perfectly curated playlist Spotify made for your morning commute? Also AI. The way your phone's camera magically makes your photos look stunning, or how Google Maps finds the fastest route, avoiding that surprise traffic jam? Yep, you guessed it. AI, and more AI. It's the invisible engine powering so much of our modern world. But what exactly is this magic? How does a machine learn to think, predict, and create? Today, we're pulling back the curtain to reveal the magic behind the machine. We're going to demystify artificial intelligence, breaking it down piece by piece so you can understand not just what it does, but how it actually works. First things first, let's clear up some confusion. The term AI gets thrown around a lot, often mixed up with scenes from sci-fi movies. So, what is AI really? At its core, artificial intelligence is a broad field of computer science focused on creating machines that can perform tasks that typically require human intelligence. This includes things like learning, problem-solving, and understanding language. But here's where it gets interesting. AI isn't one single thing. It's an umbrella term. Underneath it, you have machine learning, which is a subset of AI. This is where we give a computer a large amount of data and let it learn patterns for itself, without being explicitly programmed for every single step. Think of it as teaching a child by showing them examples, not by giving them a rigid set of instructions. In going one level deeper, we find deep learning, which is a powerful type of machine learning that uses structures called neural networks, inspired by the human brain. These networks have many layers, allowing them to learn incredibly complex patterns from vast amounts of data. This is the technology behind things like voice assistants and self-driving cars. So, when people talk about the recent breakthroughs in AI, they're usually talking about advances in deep learning. So how do we build one of these learning machines? It all comes down to three fundamental pillars: data, algorithms, and models. First, data. Data is the lifeblood of AI. It's the food, the textbook, and the experience that an AI system learns from. Without data, an AI is like a brain with no memories or senses. The more high-quality, relevant data you have, the better your AI will perform. This could be millions of images of cats to teach an AI to recognize them, or decades of stock market data to predict future trends. Next, we have algorithms. An algorithm is a set of rules or instructions that the machine follows to learn from the data. It's the recipe. There are many different types of algorithms, each suited for different tasks, like sorting information, finding patterns, or making decisions. The algorithm guides the learning process, telling the AI how to interpret the data and what to look for. Finally, we have the model. The model is the output of the training process. After the algorithm has processed the data, what you're left with is the model. You can think of it as the brain that has been trained. It's a complex mathematical structure that now contains the knowledge learned from the data. This trained model is what's actually used to make predictions or decisions on new, unseen data. So, remember, data is the textbook, the algorithm is the learning strategy, and the model is the student who has finished studying and is now ready for the test. Let's make this more concrete with an example. Imagine we want to teach an AI to recognize handwritten digits from 0 to 9. This is a classic problem in machine learning. This is the AI's school years. We start with our data, a huge data set of tens of thousands of images of handwritten digits, each one labeled with the correct number. This is our textbook. Next, we choose our algorithm. In this case, we'll use a neural network, a type of deep learning algorithm. This network is made up of interconnected nodes, or neurons, arranged in layers. When we show it an image of a handwritten 7, the pixels of the image are fed into the first layer of the network. Each neuron in the first layer processes this information and passes it on to the next layer. As the data moves through the network, the connections between neurons are adjusted. Initially, the network's guesses are completely random. It might look at a 7 and guess 1. But here's the magic. Because we have the correct label, we can tell the network, "No, that was a 7. You were wrong." The algorithm then calculates how wrong the guess was and uses this error to slightly tweak the connections between the neurons, making it a tiny bit more likely to guess 7 the next time it sees a similar image. We repeat this process thousands upon thousands of times, with all the different digits. It's a slow, repetitive process of guessing, getting feedback, and adjusting. Over time, the network gets better and better, strengthening the pathways that lead to correct answers and weakening those that lead to wrong ones. After this intense training, our neural network becomes a trained model, an expert at recognizing handwritten digits. Now that our AI has graduated, it's time to put it to work. This is the inference stage. Inference is simply the process of using the trained model to make predictions on new, real-world data that it has never seen before. Let's say you write a check and deposit it using your banking app. You take a picture of the check, and the app instantly reads the amount you wrote. How? Behind the scenes, the image of your handwritten amount is sent to a trained model, just like the one we described. The model analyzes the pixels, the information flows through its trained neural network, and it outputs a prediction. That's a 1, a 0, a 0. This is inference in action. It happens in a split second. Every time you use a language translation app, ask a voice assistant a question, or see a face tagged in a photo on social media, you are witnessing the inference stage of a trained AI model. The heavy lifting of training was done beforehand, in a data center with powerful computers. What you experience on your device is the quick, efficient result of all that schooling. The model isn't learning anymore. It's simply applying its knowledge. It's the AI, graduated and on the job, making our lives easier one prediction at a time. As it turns out, AI doesn't just have one way of learning. There are 3 main flavors, or paradigms of machine learning. The first is what we've mostly been talking about, supervised learning. This is like learning with a teacher. The AI is given a dataset where all the data is labeled with the correct answers. The goal is to learn the mapping between the input and the output, so it can predict the output for new, unlabeled inputs. Recognizing cats in photos or predicting house prices based on their features are classic examples of supervised learning. The second flavor is unsupervised learning. Here, the AI is on its own. It's given a dataset with no labels, no right answers. Its task is to find hidden patterns or structures within the data, all by itself. Think of it like being dropped in a library and asked to organize the books by topic without knowing the Dewey Decimal System. You'd start grouping books that seem similar. This is what unsupervised learning algorithms do. They're great for tasks like customer segmentation, where you want to group similar customers together for marketing, or for anomaly detection, like identifying unusual transactions in your bank account. The third flavor is reinforcement learning. This is learning by trial and error, based on rewards and punishments. Imagine training a dog. You tell it to sit. If it sits, you give it a treat, a reward. If it doesn't, it gets nothing. Over time, the dog learns that the action sit leads to a reward. Reinforcement learning works the same way. An AI agent operates in an environment and tries to achieve a goal. It gets positive rewards for actions that get it closer to the goal, and negative rewards for actions that don't. This is the technique that powers AIs that can play complex games like chess or Go at a superhuman level. And it's also crucial for robotics, teaching a robot how to walk or manipulate objects. For all its power and promise, AI is not perfect. It has a dark side, and it's crucial we understand its limitations and risks. One of the biggest problems is bias. An AI is only as good as the data it's trained on. If the data reflects existing societal biases, the AI will learn and even amplify those biases. For example, if a hiring AI is trained on historical data, where mostly men were hired for engineering roles, it might learn to unfairly penalize female candidates, even if they are equally qualified. This can create a vicious cycle, perpetuating unfairness. Another major issue is the black box problem. This is especially true for complex deep learning models. We can see the input and we can see the output, but often we don't fully understand the decision-making process happening in the middle, inside the hidden layers of the neural network. The AI might give a correct answer, but we can't ask it to show its work. This is a huge problem in high-stakes fields like medicine or finance, where understanding the why behind a decision is just as important as the decision itself. Finally, there's the problem of overfitting. This happens when a model learns the training data too well. It memorizes the specific examples, instead of learning the general patterns. An overfitted model will be brilliant on the data it was trained on, but will fail miserably when it sees new, slightly different data. It's like a student who memorizes the answers to a practice test, but doesn't actually understand the concepts, so they fail the real exam. These are not just technical glitches. They are fundamental challenges we must address as we integrate AI more deeply into our society. So, where are we headed? The future of AI is both exciting and transformative. We're on the cusp of breakthroughs that could redefine entire industries and help us solve some of humanity's biggest challenges. In medicine, AI is already helping doctors diagnose diseases like cancer earlier and more accurately from medical scans. In the future, AI could develop personalized treatment plans based on an individual's unique genetic makeup and lifestyle. Imagine AI-powered drug discovery, capable of simulating molecular interactions to find new cures in a fraction of the time it takes today. In the fight against climate change, AI can optimize energy grids, make agriculture more efficient and sustainable, and help scientists model complex climate systems to better predict the effects of global warming. It can analyze satellite imagery to track deforestation or monitor melting ice caps in real time. And in education, AI could create truly personalized learning experiences for every student. An AI tutor could adapt to a student's individual pace and learning style, providing extra help where it's needed and new challenges to keep them engaged. The potential is immense. We are moving from AI that just performs specific tasks to AI that can augment human creativity and intelligence, acting as a powerful partner in science, art, and exploration. The journey is just beginning. We've covered a lot of ground today, from the basic definition of AI to its building blocks, its school years, its different learning styles, and even its dark side. We've seen that AI isn't magic, but rather a powerful tool built on data, algorithms, and a whole lot of computation. It's a field of constant innovation, with the potential to reshape our world in ways we are just beginning to imagine. But with great power comes great responsibility. As we move forward, the conversations around AI ethics, fairness, and transparency are more important than ever. We all have a stake in this future. So now I want to turn it over to you. What are your thoughts on the rise of AI? Are you excited about the possibilities or concerned about the risks? What application of AI are you most looking forward to? Let us know in the comments below. We read every single one. Thanks for joining us on this journey beyond the known physics. If you enjoyed this deep dive and want to learn more about the science shaping our future, make sure to like this video and subscribe to the channel. We'll see you in the next one.